Hi, and welcome to today's lesson. We're going to go over equations. However, before we start, let's go over some of the stuff that we went over last time. So we went over things like algebraic expressions. Okay, so this would be something like 3x squared over x minus 5. And this is different from something like 3 minus 6. So 3 minus 6 is not an algebraic expression. It's just -3. But if you run into an expression with variables and coefficients, you know you have an algebraic expression. Another thing that we learned was terms. So this current algebraic expression that we have right now has 3 terms. So 3x squared would be a term, x would be a term, and 5 would be a term. And we also learned about coefficients. So for the first term, 3x squared, well, the coefficient would be 3, right? It's just the number that's in front of the variable that's multiplying the variable. For the second term, the second term is negative x. So the coefficient for that would be -1, right? Every variable, whether it's a or x or y or z, has an invisible 1 in front of it. Okay? So all these variables right here have coefficients of 1. And 5 would just be a constant, right? That's another thing we learned about is just number by itself that's not multiplying a variable is a constant. So if we have something like 4x minus 12, 12 or -12 would be the constant of this expression. So the other thing we learned about, besides algebraic expressions, constants, and terms, and coefficients, would be combining like terms. So first of all, if we had something like 3x and 4x squared, these wouldn't be like terms because while they have the same variable, so right there, they both have x's, the exponent on top of the x is 1. So they have different exponents. So these are not like terms. However, if you have something like 12xy and 3xy, well, these both have the same variables, and the exponents are also the same because they're all ones. This would be considered like terms. Okay? We have like terms. The thing with like terms is they allow us to combine them. So, same example, if we have 12xy and we're adding 3xy, because they're like terms, we can simply combine them into one term. So this would be 15xy. So when an important thing to note when we're combining like terms is that the variables stay the same. The only thing that changes is the coefficient. Okay? This basically says you have 12xy's and this has 3xy's. So when you combine them, you would end up with 15xy's. Okay? And that's what we went over last time. In today's lesson, we're just going to be introduced to the concept of equations. So equations is when you have two algebraic expressions separated by an equal sign. So basically, anytime you see an equal sign, you know you're dealing with an equation. So for example, here we have x squared equals 16. Well, you have an equation. Therefore, that is an equation. As opposed to something like this, where you have x squared minus 16, this is just an algebraic expression. It is not an equation. There is no equal sign. If you had an equal sign with 0 or something like that, then it would be an equation. So let's go over an example. Is x equals 10 a possible solution of this equation? Well, let's see. All we have to do to answer this question is to plug in or substitute 10 for x in our equation. So we're going to multiply 5 by 10, and we're going to see if this is true. So 5 times 10 is 50. and 50 does not equal 25. Therefore, this is false. X equals 10 is not a solution of the equation. Next, is x equals 7 a possible solution of this equation? Again, let's substitute. So we have 3 times 7 plus 10 equals 31. And let's see if this is true. So 3 times 7 is 21 plus 10. That's going to be 31 on the left side. And we have 31 on the right side. Therefore, we have a true equation. 31 does equal 31. Now, the reason equations are important is because they allow us to solve for unknown values. So if we were given something like this, where we have 3x equals 12, we can solve for x. So there are actual techniques that allow us to solve this equation called the addition property of equality and the multiplication property of equality. We will not go over that today. Today, we're just going to figure this out the old school way, which is to ask ourselves, what number, when multiplied by 3, gives us 12? So if you know your multiplication tables, we can easily solve this pretty quickly. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 gives us 12. Therefore, x equals 4. Let's do another one. In this one, we have an equation that says 3 plus x equals 36. So you can ask yourself with this one, if we, basically what this is asking is, what number gives us 36 if we add 3 to it? So if you can imagine the number line, let's say we have 36 right here. And this equation is saying if we add 3, if we go 3 steps to the right, we get 36. Well, we can easily find out what we started with by going back 3 steps. So if we start at 36, we can go left to 35, 34, 33. So going back 3 steps from 36, 1, 2, 3, well, we end up at 33. Okay, therefore, x equals 33 is our answer. Now, one term that you need to be aware of is domain. This is a very important term. You will be running across it all the time in Algebra 1, 2, and pre-calculus and calculus. And it means all the possible values of x for which the equation is true. Okay, all the possible values of x. So in this example, it's giving us a possible domain. In other words, what they think that x might be. We don't know yet, but they think it could be 20, 15, or 30. And it's asking us, which one of these is an actual solution to the following equation? So let's try to figure this out by simply substituting. Okay, so let's try 20. If we substitute 20 in for x, okay, so it's saying that it's equal to 3. Now, we just have to figure out, does this equal 3? Well, 20 divided by 10, what is that? It's 2. 2 does not equal 3. So 2 is not a solution of this equation. In other words, it is not in the domain of this equation. Let's try 15. So if we substitute 15 for x, we get 15 over 10 equals 3. Now, we can actually reduce this fraction because it has a greatest common factor of 5. So 15 over 10 can be rewritten as 5 over 2, right? You divide both the numerator and the denominator by 5, you get 3 over 2. And you can see that 3 over 2 does not, in fact, equal 3. Therefore, 15 is not part of the domain. It is not a solution of the equation. Let's try 30. So when we substitute 30 for x, we get 30 over 10 equals 3. Well, is this true? And actually it is. So if we divide, we know that 30 divided by 10 is 3, so we can rewrite that as 3. And 3 does equal 3. Therefore, 3 is a solution of the equation. Let's try another example. This one, it's asking us if x equals 2 is a solution of the following equation. So we can figure this out easily by just plugging it in or substituting. So let's do that. So let's substitute. So I'm going to replace this parentheses with a bracket. Let's just erase it. Okay. So let's go ahead and substitute two into x. Okay. So that becomes 9 times 2 plus 21 equals negative 20 times 2 plus 1. And now all we have to do is ask ourselves if this is a true equation. Okay, so 9 times 2 is 18. 18 plus 2 is 20. Now, we have to remember that there's a negative sign. So this negative sign, I made a mistake. This negative sign is being applied to the left side only. Okay. So 9 times 2 is 18. 18 plus 2. So I'm sorry, not 2. 18 plus 21. Okay. That's 9. 3. It's 39. So on the left side, we're going to get negative 39. And on the right side, well, negative 20 times 2 is negative 40. Negative 40 plus 1 is going to be negative 39. So negative 39 does equal negative 39. Therefore, we have a true equation. And x equals 2 is, in fact, a solution of this equation. Okay, let's try one last example. This question is asking us if x equals 3 is a solution of the following equation. So just like before, we're gonna substitute 3 in for x. And we want to know if the left side is equal to negative 6 on the right side. So knowing PEMDAS, I know that I have to square 3 first before multiplying it by negative 12. So 3 squared is 9. 9 times negative 12. We can break up the 12 into 10 and 2. So 9 times 10 is 90. 9 times 2 is 18. When we add, we get 108. So we have negative 108. Okay. And then 10 times 3 is 30. And on the right side, we get negative 6. So negative 108 and 30 combine to 78. Negative. And negative 78 does not equal negative 6. So therefore, x is not a solution of this equation.